All right, here we are for day 22. Almost near the end. We got quite a collection of coins, 42 in all. And we have just a few more days left before we get to wherever our vacation place is. What did we have for yesterday? Yeah, yesterday was the trying to figure out ingredients. So I guess we're pretty close to the vacation island. Closest we can get without getting wet. We build a raft. I see. So we first time reading the full text, but apparently we collected a bunch of food, and we're gonna jump on a raft and make our way ourselves to this vacation place. And that was the finding. I don't know, finding the allergens that matched up with the ingredients. One of those sort of constraint problems. I could have used something like Z3. Z3 is kind of a pain though. You have to really think about how you're gonna turn basically the whole set of data into sort of like a true false sort of thing. So I guess the model would be something like a list of ingredients, and they're matching allergen. The problem with Z3 though is it's a pain to set up stuff like enums. You can set up integers, but then you got to keep track of what the integers mean. It's sort of difficult to work with more dynamic data outside of just numbers and strings. I remember setting one up with enums previously, and it was a huge mess. Just a whole amazing amount of code just to get a few simple rules in. Not something I wanted to mess with for too long, but solving it manually certainly worked out. So let's see how we're going to do for day 22. Takes a few hours of sailing the ocean until I become bored. Found a small deck of space cards. You'd like to play a game of combat. There's even an opponent available, a small crab. Fortunately, it doesn't take long to teach the crab the rules. Before the game starts, split the cards so that each player has their own deck, your puzzle input. Then the player with the higher valued card wins the round. The winner keeps both cards, placing them in the bottom of their own deck so that the winner's card is above the other card. The winner keeps both cards, placing them on the bottom of their own deck so that the winner's card is above the other card. Okay. If this causes a player to have all of the cards, they win, the game ends. For example, this arrangement means that player 1 deck contains 5 cards with 9 on top. Player 2 deck also contains 5 cards. First round begins with both players drawing the top card of their decks, 9 and 5. Player 1 has a higher card. Okay. Once the game ends, you can calculate the winning player's score. The bottom card in their deck is worth the value of the card multiplied by 1. The second from the bottom card is worth the value of the card multiplied by 2, and so on. Okay. So basically, It's like a game of war. So let's parse this out first. We want to create 2 decks. So read all text. Decks. And what are we going to have? Deck 1 and deck 2. Oh, whoops. Put that a little too high. Alright, so what do we want? Get all the lines in the first deck. I guess we can do something like this instead. Deck 1 equals decks 0. Split this. Oh, we need to split this guy first. Split this by double new line. Again, I need to change my line endings to line feed only. And then down here, we take deck 0, we split it by single new line. We skip the first entry, and then we select the rest, and we parse it. And convert it to a list. Do the same thing for deck 2. And let's see if we got that correct. Deck 1 is 92631. Deck 2, 584710. Looks good. All right. So we need something like a while loop. So let's see. While deck 1 dot count does not equal 0, and deck 2 dot count does not equal 0, we'll play our game. So the first step is to, we're working off the top, correct? 9 and 5, 9 wins, player 1 wins the round. So let's see. Deck 1, card 0 is greater than deck 2. Oh, what do we do in the case of a tie? Doesn't say anything about a tie. It looks like we have a unique set of numbers. So I assume we can't have a tie. Alright, if deck 1 wins, then deck 2 dot remove at 0. Losing card equals deck 2, 0. The winning card equals deck 1, 0. We're going to remove these cards from both decks and then add them to deck 1. We add the winning card first, and then we add our losing card. Alright. Else we do the same thing, except we reverse this. The losing card is deck 1, winning card is deck 2. And we add these to deck 2. Alright, and once that finishes, we need to winner equals deck 1 dot count. It's not equal 0. Then the winner is deck 1, else deck 2. And for the winner, how are we going to do this? We work from the bottom up. So I guess we can say you can reverse this, right? For each card, we're going to say results plus equals card times count. And we're going to return the results. And let's see, 306. That's the correct answer. All right, so let's try that with the puzzle input. We get this number. And it looks like we got it. All right, part 2. You lost to the small crab. You challenge the small crab to a game of recursive combat. Recursive combat still starts by splitting the cards into 2 decks. You offer to play the same starting deck as before. Then the game consists of a series of rounds with a few changes. Before each player deals a card, if there was a previous round in this game that had exactly the same cards in the same order in the same player's deck. Ooh, that's a doozy of a sentence. The game instantly ends in a win for player 1. Before either player deals a card, if there was a previous round in this game that had exactly the same cards in the same order in the same player's deck, previous rounds from other games are not considered. Otherwise, this round's cards must be in a new configuration. The players begin each round by drawing the top card of their deck as normal. If both players have at least as many cards remaining in their deck as the value of the card they just drew, the winner of the round is determined by playing a new game of recursive combat. If both players have at least as many cards remaining in their deck as the value of the card they just drew, the winner of the round is determined by playing a new game of recursive combat. Okay. Otherwise, at least one player must not have enough cards in their deck to recurse. The winner of the round is the player with the higher value card. Oh boy. Let's see. As in regular combat, the winner of the round, even if they won the round by winning a subgame, takes the 2 cards dealt at the beginning of the round and places them on the bottom of their own deck. Note that the winner's card might be the lower value of the 2 cards. If they won the round due to winning a subgame. If collecting cards by winning the round causes the player to have all the cards they win and the game ends. Here's an example. During a round, if both players have at least as many cards in their own decks as the number on the card that they just dealt, at least as many cards in their own deck as the number of cards they just dealt. The winner of the round is determined by recursing into a subgame of recursive combat. Player 1 draws the 3 card and player 2 draws the 7 card. This would occur if player 1 has at least 3 cards left. Well, this is hard to follow. To play a subgame of recursive combat, each player creates a new deck by making a copy of the next cards in their deck. When do you play recursive combat? The game consists of a series of rounds with a few changes. Otherwise, this round's cards must be in a new configuration. The players begin the round by each drawing the top card of their deck. If both players have at least as many cards remaining in their deck as the value of the card they just drew. Otherwise, at least one player must not have enough cards left in their deck to recurse, the winner of the round. Okay. The winner of the round takes the 2 cards dealt by the round and places them at the bottom of their own deck. Player 1 draws the 3 card, player 2 draws the 7 card. This would occur if player 1 has at least 3 cards left and player 2 has at least 7 cards left. Okay. Play a subgame. Each player creates a new deck by making a copy of the cards on their own deck. During this subgame, the game that triggered it is on hold and completely unaffected. No cards are removed from players' decks to form the subgame. For example, if player 1 drew the 3 card, their deck in the subgame would be copies of the next 3 cards in their deck. Okay, so this one triggers... Why would this one trigger a subgame? Player 1 plays 4, which is, yeah, he has 4 left, but player 2 has 4 as well. At least as many cards in their own deck as the number on the card they have just dealt. Not exactly at least. So he has at least 3. In this one, he doesn't have at least 7. Okay. Alright, so we can start by doing our regular playthrough. And then once we get to... I guess we have different conditions for winning, right? We need something in here that says whether to begin a recursive game. And we can do that by saying if deck 1, card 0 is less than deck 1 that count. Or less than or equal to. And deck 2, card 0 is less than or equal to deck 2.count. Then begin subgame. And we had conditions for a win. There was a previous round in this game that had exactly the same number of cards in the same order in the same player's deck. This game instantly ends in a win for player 1. There was a previous round in this game that had exactly the same cards in the same order . I see. So we need to keep track of games. How are we going to do that? We're going to, I guess, just keep a list of lists, right? Or maybe a hash set. Would probably be easier to search through. That would be a list of integers. List of integers. Previous game equals new. we gonna go into sub games from? All right. So anyway, if we say deck 1, the previous games contains deck 1, deck 2. Then we don't quit. All right. I always have to figure this out. We have a list of integers. Is my hash set gonna know that these are the same? Oh boy, hopefully. All right, sub game, deck 1, deck 2. I think that's it. What were the other winning conditions? This round's cards must be in a new configuration. Players have at least as many cards remaining in their deck as the value of the cards they just drew. Otherwise, at least one player must not have enough cards left in their deck to recurse. The winner of the round is the player with the higher value card. Okay. We need to play a sub game. How does that look like? What do we return? So let's see. We start a sub game with 4 and 3. The winner of the game 2 is player 2. So 3 and 4 are added to player 2's deck. Whoops. I guess we can just return the winning card. This is going to be a new list called deck 1. New list deck 2. When does sub combat end? During this sub game, the game that triggered it is on hold and completely unaffected. No cards are removed from the player's deck to form the sub-game. Okay, so we can actually move all of this into this sub-game thing. Let's call this deck A, and no, I want deck 1 and deck 2. Maybe sub deck 1 and sub deck 2. Deck 1, and just a sub deck 1. No. Why am I going backwards? Okay. Replace. All right. Let's do the same thing for deck 2. All right, at the completion of sub-combat, what do we need to do at final? Yeah, we need to figure out player 2's deck. Interesting. How are we going to return from this properly? I guess we can return the winning card and also the winning deck. I guess that's okay. So here, our winning deck is going to be same as what we did before, right? Sub deck 1, sub deck 2. Dang. Maybe just a Boolean for the first winner? Boolean and a list. Maybe another one here to say first game. Main deck and winner equals sub deck 1 count not equals 0. True. Else false. All right, and then up here, if sub-combat of deck 1, oh wait. Basically need something like this. Deck 1 card, deck 2 card. If sub-combat of deck 1 and deck 2 false dot item 1, this is true, then deck 1 was the winner. So we say oh, this needs to be subdeck. I need to be careful with that. Then subdeck 1. If subdeck 1 is the winner, we add the winning card, which is deck 1 card. And the losing card, which is deck 2 card. Right? For this one that kicked off game 2, player 1's card is 4, 2 is 3. So player 2 wins the round. And player 2 gets 3 and 4. Okay. So deck 2 adds deck 2 card and then deck 1 card. All right, so this we say what are we doing? I mean, deck equals sub-combat, deck 1, deck 2, and true for this is the first game. What? Now let's see. What do? We do this, right? Hmm. Solve 1. Why are we still at solve 1? Oh. Let's just disable. Oh, how do I want to do this? I don't want to ruin my first solution. I guess we'll just do something like this. Deck 1A, deck 2A. And then we'll create some copies. Down here, we use deck 1A and deck 2A. All right, part 2 says 145. Is that the correct answer? No. So let's get some debugging going on. What am I doing? I want to see. Let's just print the decks. Layer 1, layer 2, and we'll put string.join, comma, deck 1, and then deck 2. And where are we going to print this out? I guess that's the end, I suppose? Or at the beginning? I guess here, branch subdeck 1, subdeck 2, and then one more time here at the end. Oh. Let's pause. I have 2 games. Round 2. $19.43.2. Oh. Let's get this test input. This one? Yeah. Oh, we weren't even testing the right thing. Oh, we still got an incorrect answer. Okay, looks good. Oh, you know what? I think I know what I'm doing. Previous game. So I guess I can check this at the end instead of up here. Oh, wait, we also need to figure out the winner. If there was a previous round in this game that had exactly the same cards, then player 1 is the winner. I guess we'll have this auto win thing here. And if this condition applies, then we'll set the auto win to true. Winner equals if auto win or subdeck 1.count does not equal 0, then player 1 is the winner. And we'll get the winning deck if this auto win condition applies. Okay, let's try that. Why are you exiting so fast? Why is the deck the same? Oh, yeah, this hash set is not working the way I thought. What's a good way of storing these? How about... How about I join these two? Oh, can't do that. Previous games. Let's try a hash set of integer arrays. It's going to be a single integer array that I'm going to create by saying new a list based off the subdeck 1. We'll add subdeck 2. And we will throw this into our previous game. I don't know how efficient that's going to be. $323? Is that the right answer? No, it's not. We should have gotten 291. $75624. That's not right. So let's take a walk through this list. All right, so game 1, good. Then 6-4, good. 3-7. 7-10 A2, that's good. This looks good. 5-6, 2-7, 6-4, 7-3, 4-9. Ooh, what happened here? 4-9-8. What happened to 5-2? Oh, why didn't this one start? No, I guess that wouldn't. What happened to the winners from this one? Hmm. Yeah, subgame started for some reason here, but it shouldn't have. Subdeck 0 is less than or equal to subdeck 1 count. So 5 should not be equal to, oh, it shouldn't be less than or equal to, it should just be less than, because we shouldn't be counting ourselves, right? All right, let's try this again. We got 326, which again is not correct. This time we started the subgame at the correct position. Right, 4-3. The subgame starts with 9-8-5-2 and 10-1-7. Where did this 6 come from? Oh, let me read the rules again. Making a copy of the next cards in their deck. The quantity of cards copied is equal to the number of cards they drew to trigger the subgame. Okay. So this guy should have only drew 3 cards to start the subgame. So subdeck 1, take deck 1 card. And subdeck 2, take deck 2 card. Okay. This time we got 291. I think that was the right answer, yeah. Alright, let's try this with the big stuff. Let's get rid of our print statements and try to run this. I thought I said to get rid of those. Okay, one more time. Ooh, Yep, I guess my solution was not the proper one because this is taking way too long. So we probably need a memoized solution in here. I'm gonna quit this before it eats up all my memory. So when we hit subcombat, I guess I can create a dictionary of solutions like this. An integer array and I guess just a Boolean that tells us who's the winner. And when we get to this point, we can do something like this. Demo contains game data and return. I don't like the fact that I'm creating a new list every time I'm trying to do this. Otherwise, we will add it down here. Demo add game data 2A and the winner value. Let's try this with our test data real quick. Okay. Try this with our real data. Yeah, it's still running a ton. I wonder, is this memo ever being used? It doesn't look like it. Seems like I'm always getting unique decks to check. How would I reduce this then? Am I ever getting to this auto win solution? Doesn't seem like it. previous games is a huge number. Hmm. How would I improve the performance here? There's got to be some area where I can skip some processing. So memoization didn't seem to be it. I'm probably wasting a lot of resources trying to find previously known solutions. I guess if I knew the solution previously, I would have triggered this auto win, right? Hmm. I don't see sub-combat being called. Did we enter a loop somehow? Let's see, this says it's not the first game. So we're stuck inside of some sub-game. The previous games listed is a huge number. We do have some listed in known games. So this should tell us that we only went into 6 or 5. Yeah, 6 sub games. Hmm. Wonder where am I spending the majority of my time here? So let's see. So I'm looking at some CPU data. Can I simplify this previous games thing? Deck 1. Can't imagine that's going to speed it up too much. This memo thing is barely called at all. Hmm. Where are my known games? That's memo, right? So that's kind of where we were previously. Once we hit game 6 or whatever, it just loses its mind. Are we in some sort of infinite loop here? Looks like it. What is going on with this game? I guess one other thing we can do is use immutable lists. We are doing a remove at, removing the first entry, which can be kind of slow for lists, I believe. Let's get some immutable lists going on here. So immutable. That's going to be mutable list. To immutable list. What do we do? How do we create a new immutable list? Oh, I guess we... How do we create a copy of one? Yeah, we'll do this. Hopefully that means it's actually cloning the object. Alright, so for this guy, it's throwing some immutable lists all over the place. Yeah, it doesn't magically solve my problems here. Hmm. Oh, we've somehow created some loop. Why? That's because we are working with immutable lists. So we need to replace our current list with the new one. Uh-oh. We're breaking things. Subdeck 1, subdeck 1. Hmm. We've broken it somehow. Wait, that's the correct. Why is the result 314 then? Oh. Again, because this is an immutable list and we didn't reverse it. 391, okay. Does this help at all for... Okay. We don't want all that printing. Yeah, we're pretty much back where we were at. I can't really tell if it's running faster or not. I I can't imagine removing the first entry would be that big of a deal for a list anyway. I know Mutable List is pretty good at doing inserts in the middle. It just seems to get stuck in this. What is it, seventh game? Hmm. I guess the previous games, if we have a total of 23 items, 23 different cards. That would be 23 factorial for the number of different possible games, right? Well, I guess sub games are would be typically smaller, right? Oh, yeah, in this sub game, you only have 23 cards as opposed to 50, I guess, because you're looking at a sub of the original cards. But still, 23 factorial is like a crazy high number. Is there a way for us to... What are we doing? Are we ordering this list? Is that what we're doing? Hmm. I guess it would help if I can predict a winner in a sub game. Hmm. We're still stuck in game 7. Hmm. Maybe I should memorize the previous game? But how would I do that? I mean, you can't really do that. Mm. Like a super inefficient sorting algorithm. Well, yeah, I can change these to um, queues, I guess. Well, might as well see if it makes a difference. Because we're basically performing NQ and DQ. I guess I could keep these as lists so it doesn't ruin the first question. These will be queues. So, to list, and this will be Alright, so let's rework all of these. Oh, we can't. Let's see. Deck 1 card is less than or gotta change this to less than or equal to. Deck 2 card is less than or equal to subdeck 2. We don't do this anymore, or this. Hmm. One card. Deck 2 card. Winning card here is deck 1 card. I guess I could have done that way up top. Let's see. Winning deck is a Q. Add that to a list. Let's try with our test input real quick. Nope. Alright, let's fix this real quick. See what's wrong with our new setup. No. Nine two six three one. Okay, looks good. But doesn't look like we're going into a sub. The heck happened here? Let's see. Subdeck 1 count does not equal 0. Alright, we DQ deck 1. Oh, we don't do this. Oh, that's right, yeah. Oh, what am I doing down here? There we go. Alright, back to running this thing. Let's get rid of those print statements. Alright. Going into a super infinite loop. Hmm. I wonder if this is my auto win thing even working? Was this a factor in the previous one? No, it wasn't. There's there's a good chance that this guy isn't working. And how would I tell? let's do a quick test down here. Let's create our integer array hash set. Let's add an integer array, 1, 2, 3. Okay, so our previous game check thing is definitely not working. I thought I could hash a integer array, but it turns out I cannot. Hmm. I guess maybe because it's using the equals comparison. And I think arrays need to have the sequence equals. Hmm. What can I hash? What's a lookup? Hmm. Weird. I want to search an list of integer arrays. Hmm. But this is going to be super slow. Zero. Really? Previous games 323. Game data is. Hmm. Well, it looks like it was my previous games search that was kind of the big issue. But why am I getting a zero result deck? It worked fine for this one. Oh, maybe because it turned out to be an auto win? Oh, this is. Game instantly ends in a win for player 1. Previous rounds from other games are not considered. Otherwise, this round's cards must be in a new configuration. Players begin the round by each drawing the top card of their decks as normal. Subdeck 1 is 50. Subdeck 2 is empty. Let's see. What did we mess up here? Auto win is false. Subdeck 1.count does not equal 0. So winner should be true, right? Yeah. And then down here, if auto win is... Oh, this should be an or sign. Okay, I think we're about there to an answer. Yeah, I just wasted a ton of time because of that hash set comparison. I'm still not sure what I would do. I mean, that hash set is still pretty slow. No, that's not the right answer. 33,055 is Now, I wonder if there was a previous round in this game that had exactly the same cards in the same order in the same player's decks. The game instantly ends. So I think what it's saying is that I need to bubble up this this auto win thing. So let's see, we can do something like this. Let's add another boolean in here. And we'll put it in here as well. And if we run a sub-combat game, sub-game we say if sub-game item 2, which is our auto win, if it's true, then we need to instantly return with an auto win result. Else, if item 1 is true, then there's a regular win for user 1. Let's get rid of the memo thing. I don't think we're actually using that. So the result this time is 9,623. And that's definitely smaller than what we had before. 9,623. Answer is too low. Oh. We need to bubble up the winning deck too. How do we do that? I guess instead of breaking, we can just return just the values of the subgame, right? Except we also need to set the winning deck. If first game or auto win. What do we get this time? 1761? That's way too low. The previous answer was 9,000. And that was too low. So let's see, do we not bubble up the winning deck? Before either player deals a card, if there was a previous round in this game that... so on. The game ends in a win for player 1. The previous rounds from other games are not considered. What... in this case, what deck do we consider? Oh, I think it's saying just the game ends. I think I misread that. So let's go back to where we previously were. Okay. So if we got an auto win, then player 1 wins. Ooh, can we reverse a queue? No, we turned it into a list. $33,055. That's what we had previously, right? Yeah. Dang. Am I possibly adding them in the wrong order? No. winning player's score is calculated from the cards they have in their original deck. Same rules as regular combat. Yeah. I mean, we're still getting the correct answer. You know, what could be potentially an issue here is the fact that we're creating an array by just joining the two lists. There could be a case where it's not exactly the same. How about that? We put a 0 in the middle of them. So it should prevent the trigger from occurring in certain cases. All right, we have 32,000 this time. Is that lower than? Yes, it is. So let's try this. 32,000. There we go. Yeah, it was basically this guy. How did I do that? It took a lot longer than it should have. Yeah. I didn't get a very good rank that time. I made it way too... I mean, I should have started with a Q, obviously, since I was removing from the beginning and adding to the end. So, or adding to the end, removing from the end. First in, first out. First in, last out? So yeah, I should have picked the right data structure. And then this, determining whether the game has been seen or not, that could have been a whole lot more... Well, I didn't even do it correctly. I thought you could take an integer array and just throw it in a hash set, and it would create an appropriate hash that represented its, internal contents, but that's not really the case. So instead, what I had to do is use link to do the sequence equals comparison, which is the correct comparison for two arrays in C#. And then the other thing is the way I saved a game. I basically saved it as deck 1 might be 1 and 2, and then deck 2 might be 5 and 6. So I considered that, a game, but in reality, it could have been the case where deck 1 only had one card, and then deck 2 had the cards 2, 5, and 6. And that would have been an exact comparison. And we fixed that by adding in a 0 to separate the two lists. So 1, 2, 5, 5, and 6, and so these two lists, they wouldn't be seen as the same anymore. Where we had one game where player 1 had cards 1 and 2, and player 2 had cards 5 and 6. But in another game, player 1 only had cards 1, and player 2 had cards 2, 5, and 6. We should be seeing these as two separate games. So yeah, this one took a bit of time, but I'm just happy I got through it. So that's it. That's it for this one. We'll see you tomorrow for day 23.